So good morning everyone. Welcome to lecture 31 of the course on data structure and algorithm. So in today's class, we shall be continuing the discussion on binary search tree. We shall discuss about several operations like searching, insertion, um, and the deletion of a node from a binary tree. Okay. So I have shared my screen. Hope you can see my screen. Is my screen visible to all of you?
Yes, sir. Please go.
Uh,
Yes, sir.
so let's take an example. Uh, Okay, so let's take this example. Okay, so our job is to construct this binary search tree. Okay, and this binary search tree is following the principle that any left subtree node will possess a value which is less than the value of root node, and any right subtree the node any node containing belongs to the right subtree will have a value greater than or equal to the value of the root node. So here 15 less than 20. So 15, 10, 17, all of them are less than 20. So they forms the correct left subtree, and here 25, 30 are greater than or equal to the value of root node. So that's why they constitute correctly the right subtree. So the overall this tree is following the principle of binary search tree. So it's a binary search tree. Now we are going to construct it. Okay. As we know that okay, so each of this node is nothing but a structure, because they will have multiple types of components, elements, structure elements. The struct tree node. Okay, BST node. One so how many components will be there? A value and two linker parts, right? Two pointers, left pointer, right pointer, left pointer pointing towards left child, right pointer pointing towards right child, and the data part containing the value. So, and each of the pointers, left pointer and right pointer, must point towards another node of its own type, and the type of each of the node is start based node. So their data type will be start based node. So start based node star left, let's say int data, okay, not level, struct based node star right, and that's it. So this defines the template or the structure of a node in a BST. Okay, then here I'm actually okay. So you know that we should have one logic we told about in the yesterday, that is there must be a pointer which should point towards the root node throughout the operation on a BST. So this pointer, let's say its name is root. Struct BST node star root. Okay, and we want to initialize it null. Initially, BST is initialized to null. Initially, BST is null. That means we are going to construct this. And initially, the tree is empty. Yeah. Okay, so initially root is empty. It's particulars now. Okay. Next, actually we will implement inserting operation, means traversal operation, and insertion and deletion. So we can create a menu option. No problem. হয়ে গেছে? হ্যাঁ দিচ্ছি। Excuse me for a second. So return 0 to the. Here we go. We are going to insert over here. So let's ask the value from the user. Then call a function insert to pass the information of the root, then value. Okay. Then insert. So here, I mean, the ampersand of root is passed through the function call, and which can be received by a structure pointer to pointer. So start.
স্যার বলছিলাম যে রুটটা যদি গ্লোবাল ভেরিয়েবল করে দিই তাহলে
Yes, you can do that.
ওটাও করতে
You can do
ও
that. No issue. No issue.
ওকে স্যার ওকে
Start BST node star star P. That's it. So here P is equal to ampersand of root. That means star P is equal to root. Anyway, okay. So in the picture, we have asked the user a value to be inserted in the BST, and the user has given the value 20. So first of all, you need to create a memory allocation like this. Like this, and so that it will have three components. One is the left pointer, middle one is the data part or the label part, and the right pointer, rightmost part is the right pointer. Okay, like this. So you want to create this. Simply, it can be done. হ্যাঁ ঠিক আছে তুমি কটার দিকে আসবে হ্যাঁ শিওর ঠিক আছে হ্যাঁ So this blank is created. So next, I'm going to assign immediately. We want to this. So by doing this, we have here it is 20. Okay. So this is not a problem. And then you know, so then the root pointer must point towards this. And to do so, root is not here accessible. Star p. Star p equal to root. So star p equal to dump. Okay. Now this is applicable only for the case when BST is empty. Now this is going to the first node of the BST. Then this should be operating. Okay. So what we can do here? Okay, we will do that later. If star p is equivalent to null, that means the linked list is BST is empty. Then we should do this. Now, second time when insert function is called, user has given another value. Let's say 25. Let's say 25. So 25 is to insert it here. So insert is called. This function invoked. Here it is coming. So temp. So up to line number 42, what happened? This has happened up to line number 42. Oh. So 25. And it is the left pointer, right pointer, those are open. And those, if you make them null up to line number 44, so this is null. Okay, but after line number 44, we need to find the position of insertion. Okay, so that means here we have to find the position of insertion. Means we have to now apply the searching or traversal. So we have to build. Anyway. So what we can do in two ways we can do that. Either we can write the program for traversal over here, or we can define another function which will do find the position of the insertion and return the position. Okay, and here we will do that. Okay, so better we will implement a flexible thing. So let's define another function and call that. Okay, that function will do find the position of insertion by traversal mechanism. Yes. So okay. So I'm calling here a function. So if p this is null, then it's fine. Otherwise, we will call a function traversal traverse function. Here I want to pass ampersand root. So p. Okay. Okay. So p um, and then we need the value. So okay. it will return something. So let's we will do that later. No issue. So here let's define the function traverse. Struct is to node star star p int value. Okay. So here, you know, p equal to ampersand root. Why? Because we have what is coming p. What is p? Ampersand root. So ampersand root is passed. So ampersand root, right? And we have used a star star p, that is pointer to pointer, to collect the incoming address of pointer. Okay. So that here star p equal to the value of root. Okay. What happened? F. Okay, so F is pointing towards this. Now we want to do the homework. Okay. So if is equivalent to null, then p is empty, and then return uh, else you don't have to consider this case if condition, because the tree is non-empty in our case. We are discussing about non-empty. If f is obviously f is not null, we will check here. If if the value is greater than or equal to f pointing level. Okay. So if this condition is satisfied, greater than equal to satisfied, then what we shall do, we will not insert that value 25 as right child of 20. Rather, we will continue along the right subtree. So that means if value greater than equal to f pointing level, let me put it in a bracket. Right? Okay, if a pointing level, that means this path is chosen, this path is chosen. Okay, so we will move on. Move on means, how can we move on? With the help of pointer f. Currently f is pointing towards it.
Sir, f equals to f pointing right করলে হবে।
Yes, yes. Okay. Okay. With the help of this f pointing right. Now in this case we can have else part. What is the else part? That here value is, of course, if greater than equal to condition is false, the only condition which can be true is less than is satisfied. So value less than f pointing level. That means this else condition is satisfied. So in that case, what you are going to do, here again you want to move on. So if this path is not chosen, if this path is chosen where less than condition is satisfied, so you have to move on, and move on means you have to go to the next node. How can we do that? If equal to
So that equals to F pointing left.
yeah, sure. Okay, so this is the case. Now in our example, let's iterate. So f equal to the f pointing towards 20, and then in the code, if not equal to null, not equal to null, so it's coming under else part. So is the value 25 is greater than equal to f pointing level? Yes. So this if condition is satisfied, and then f equal to f pointing right. That means f now has reached f equal to f pointing right means f has now reached this position. That means f now has become equal to null. Okay. So what is our expectation? Our expectation is that uh, we want to move on along the right subtree or left side tree till we achieve something. Okay. So means what? We are trying to, in other words, see in the picture. Suppose we want to insert that value 35. Suppose not 25, 35. So what is the process? The logic is first we are comparing 35 with the value 20, and it allows me to move on along the right subtree. So I have chosen this path and ultimately reached this node. Comparing 25 and 35, 35 is greater than or equal to 25. So again, the right subtree is chosen, reached the value 30. Comparing 35 is greater than equal to 30. Okay, so you can choose a right subtree if available. Then you will move on and ultimately come to at the end. If that position is vacant, you can insert over here. If that position is not vacant, insertion is not possible. Yes, and that's it. So we have to keep on moving along the left subtree or right subtree till we reach the leaf node. So ultimately, this process should be repeated until you reach the leaf node. Okay. So how can we achieve this? How can we do that code?
So while if not equal to null.
Yes, we can do that uh, while okay, we can do that, but using while condition it will be difficult because here what I want to bring the concept of recursion, recursive function call. Okay,
Yes, sir.
recursive function call. So if equal to f pointing right, then in other words, okay, so we are doing this. We're calling a function traverse ampersand f pointing right comma val. Okay, Now try to understand this. Let's try to understand. Keep okay. So this example 35. Okay. Yeah. Now it's fine. So initially f was pointing towards 20. F is not equal to null. So coming under else part. If value is greater than equal to, value means 35. So 35 greater than equal to 20 satisfied. What is done? A recursive function is called. It has called itself again. So traverse, what is f pointing right? F pointing right means this node 25. This is f. So f pointing right is 25. So the address of 25 and the value means 35 are passed through the function call. So again, from this line, the program control comes over here. Star star p, address is coming, address of a pointer is coming, so star star p. So now p becomes equal to ampersand of 25 and value is again 35. Again the process is restarted. Okay, so f equal to uh, yeah, so again f equal to star p. So again as a fresh, this is pointing towards, f is pointing towards 25, value is 35. F equivalent to null? No. So if coming under else part, so if value that is 35 is greater than equal to f pointing level that is 25, then f pointing right. F pointing right means 30. So address of 30 and the value 35 will be again passed through the recursive function call. So again from this position, a function is invoked, same function is called. Coming over here, again p becomes equal to ampersand of 30. ঠিক আছে, value equal to 35. Then f equal to star p. What is star p? P equal to ampersand of 30. So star p equal to this. So f equal to, f is pointing now towards 30. Okay, f is now pointing towards 30. So in this way, you see, f is moving through this recursive function call. So f is pointing towards 30. Now is f equal to null? No. So coming under else part, is the value 35 is greater than equal to f pointing level? Yes. So again, traverse function will be called with f pointing right, ampersand of f pointing right. Means, what is f pointing right? Null. So that null is coming over here. Okay. So f equal to now equal to null. ঠিক means in this situation, uh, here it is to null. To null আছে, here it is null. So f is now pointing towards null. Null. So return f. So f should point return null. That is not expected. The position of insertion means here. So what we should check, that is we should check that if its right child position is empty or not. So what we are writing over here, so that is if f pointing right, so if f pointing right is equal to null, then position found for possible insertion. Okay, and then return f. So if we do that, so then it will return. So ultimately, so where it will stop, say let's say, so again repeating from the start, starting. Let's understand from the beginning. So initially, F was pointing towards 20. Okay. So if F pointing right equivalent to null, F pointing right means 25. Is it null? No. Coming under else part. So value 35 is more than 20. So it should follow the right subtree, and that is done by this traverse function call. You know now. Now P is equal to ampersand of 25. So F is holding the address of 25. F pointing right equal to null? No. Coming under else part, value 35 is greater than equal to 25. Yes. So again, recursive function call is done. So ampersand of F pointing right. F pointing right means F is pointing towards this. So F pointing right means 30. So F pointing right, address of 30 and value 35 is passed. So again, as a fresh, P becomes equal to ampersand of this pointer, so that star P equal to 30, so that F equal to star P equal to ampersand of 30. Okay, so now F is pointing towards 30. Please understand now. F equal to ampersand of 30, F is pointing towards 30. So is F pointing right equal to null? Yes. So position found for possible insertion, return F. See, if this F is returned, that means F is actually returning the address of this leaf node, of which right child will be the user given value 35. So this F is returned to this place here where the function was called. Okay. Okay, so someone must store that, let's say ins star ins. Okay. Yeah. With the help of insert, so ins equal to ins insert, ins equal to f. So ins is now actually pointing towards this 30.
স্যার
Okay.
একটা জিনিস জিজ্ঞেস করবো?
Yes.
স্যার বলছি এফ যেটা আছে পয়েন্টারটা ওটার ডেটা টাইপ তো স্টার স্ট্রাক্ট বিএসটি, কিন্তু ট্রাইভার্সের তো ডেটা টাইপ ইন্ট স্টার। তাহলে রিটার্ন এফ করলে কি মানে কি হচ্ছে ওই জায়গাটা?
কোথায় বুঝলাম না, লাইন নাম্বার বলুন।
স্যার 56 এফ এর যে ডেটা টাইপ
হুম।
সেটা তো স্ট্রাক্ট বিএসটি নোট, কিন্তু 54 এ ফাংশনের ডেটা টাইপ তো ইন্ট স্টার, তাহলে রিটার্ন এফ করলে কি হবে? কারণ
হ্যাঁ, রিটার্ন
এফ এর তো ডেটের ডেটা টাইপটা তো আলাদা।
এফ এর ডেটা টাইপ আলাদা বলতে
ফাংশনের ডেটা টাইপ আর এফ এর ডেটা টাইপ তো সেম করছে না, ওই জন্য রিটার্ন
ও
তাহলে কি করে?
ডেটা টাইপ বলছো, ডেটা টাইপ হ্যাঁ, রাইট রাইট। ওকে, রিটার্ন টাইপ করো, ডেটা টাইপ না, এটা বলে রিটার্ন টাইপ ফাংশন। আচ্ছা, ins equal to traverse p, so ins got the value a position, this one. So now as it's the right the child position is vacant, so now you can do the connection. What kind of connection? So in this picture ins is pointing towards this. Okay, so ins pointing right should be equal to 10.
স্যার বলছিলাম যে কানেকশনটা কি ইনসার্ট ফাংশন? ও সরি স্যার, না স্যার ঠিক আছে।
ঠিক আছে, হয়ে গেল। Here a picture. So in this way, we have successfully inserted a right child, and in a similar way, we will do the left child insertion anywhere in the tree. ঠিক আছে? So this is the idea how we can do that. So 25, that's fine. Now to validate the, of course this code is not final because this is not yet done properly. Yes, sir. Okay. So you will use this code and modify the code. Okay, update the code to run to insert at several possible positions. You will try. There are four test case is possible in this case of insertion. Insertion. That is number one. Insertion test cases. Very interesting problem. And please try to practice program implementation of this because you become slow, no problem, but you code on your own. Okay, whatever slow হলেও কোনো অসুবিধা নেই, but the thing is this kind of problems are coming in campusing, so it will boost you, it will help you a lot. Okay, and also in some other cases where programming skills are required. So the insertion test case number one. So left child, left child means left child insertion. We are inserting a new node that ultimately becomes left child or right child of another node, right? So it may be left child insertion in a subtree, in a left subtree. It may be right child insertion in a left subtree. That is also possible, right? বুঝতে পারছি? একটু সারা শব্দ দাও।
Yes,
হ্যাঁ
sir.
স্যার,
হ্যাঁ, সবাই একটু বলো।
Yes,
ভয়
sir.
পাচ্ছি নেই, একদম সোজা জিনিস। ঠিক আছে, একটু ইয়ে করে করতে হবে। রাইট চাইল্ড ট্রি, ওই একটা দুটো এক্সাম্পল বলবো ফাংশন, বাকিটা তোমাদেরকে করতে হবে, নাহলে সময় পাবো না শেষ করতে সিলেবাস অনেক বড়। রাইট সাব ট্রি। Okay, these are the four test cases main. There may be other test cases if you can find out. So left child insertion in left subtree means কেমন টাইপে, এই মনে করো 10 is inserted in a left subtree, first one. 17 is inserted in a left subtree, second one. Left child means somewhere here, left child inserted in a right subtree. That may be a case. You have to validate this. You have to verify whether your code is able to do the third or not. Right child insertion in a right subtree. So what we have done in the program, that is the fourth case. That is the right child insertion in a right subtree. So you try with others and accordingly update the program. Okay, and in so one thing for your own for your visualization purpose under convenience, actually I have shown you the requirement of another traverse function, but it is nowhere used in any book. এটা কিন্তু পাবে না বইতে, ঠিক আছে? তো এটা তোমাদের কনভিনিয়েন্সের জন্য এটা বললাম, কেন কি in many of the book, whoever has written the book and based on the recursive logic, recursive implementation, they have actually done recursive insert function, not recursive traverse. But if I explain you from the beginning the recursive insert, it will be very difficult. It may be difficult to understand. That's why I just call the function, implement the function insert as a normal function, function traverse which is recursive in nature. But ultimately, once you digest this concept, then you will feel that it is not at all required, the traversal function, but we can do the recursive insert BST over here. No need to call another function and make it recursive. Rather, we can make insert function as a recursive function and achieve the same thing. But once you digest this, then you will get the feeling. You will understand how we can make insert function as a recursive insert function and achieve the same thing. Okay? So this is for your own convenience purpose. Okay. Anyway, so this is all for today. So see you in the next class, probably after the class test. Uh, if you have any query, you can ask me.